There'd be some protein in the cheese. There'd be some carb in the chips. And there'd probably be some fat, some lipid in the cheese as well.
What about potatoes?
Potatoes are starches. That would be a carbohydrate. Yep. What you ate just for dinner. If you can't remember your dinner, you can do what you just ate for lunch. So lipids are fats. Carbs are your starches and your sugars. And proteins are, usually a protein is an animal byproduct. So your cheese usually has some protein in it. Milk has some protein. Meat for sure has some protein. There are some vegetables that have protein in them. But just for the sake of right now, we're gonna focus on the meat. And fries, well, that's a potato. And a potato's a starch, so that'd be a carbohydrate. Protein. Yes, ma'am. Yes, ma'am. Tamales, you've got the meat, the paste, right? The breading around it, the dough, that's going to be a carb. And there's probably some fat in it as well. So you've got a little bit of all three.
What about if you had like boiled eggs?
Eggs are protein.
So where put that right here?
Under protein. Yes, ma'am.
Mm-hmm.
Can I what, sweetheart? And I doubt you're doing anything to justify it, right? Yes, Daisy. Okay, so a spaghetti's got pasta, which is a starch, so that's a carbohydrate. Did you have any meat in the spaghetti? So that's your protein. That would be a starch. So you've got starches and you've got protein. Okay. If they cooked it in any oil, then you've got your lipids as well. You put it under carbohydrate. Yes, ma'am. Well, the beef was going to be your protein, right? And then you just write beef under protein. And then the stuff for the pie crust, that's going to be a carb. And then the kind of filling on the inside, I'm sure, is started with a roux, which requires butter. That's your lipid. You can just put sauce. All right. Here's the point of this. So stop writing, halt your discussions, and listen. We're about to start our investigation into biomolecules. There's more than just 3 of them, as you're going to see here in a minute. But this is something very relatable for you. You are around and you consume biomolecules every single day. So now I want you on your C notes. Here's your EQ. Do we have to copy EQs word for word? No. So if I were writing this EQ and I knew that I didn't have to copy it word for word, I might choose the word, oh, that's a pen, not a highlighter. Let's try that again. I would choose the word distinguish between biomolecules. It is not working. Hang on, I think I can fix this. Yeah, it's connected to the overhead. Cancel. All right, so display, duplicate. Now I think we're going to get it. Andrew. Let's try that again. So if I were you and I were having to write this EQ, I would just put distinguish between biomolecules. Because that's all we're doing today. The other stuff that's in this EQ, we're going to work towards throughout this unit. Today we're just doing the first part. We are at level 1 thinking. We're just going to build our foundation. Here's your objective. Just distinguish between biomolecules. Your objective is functions of 4 macromolecules, carb, protein, lipid, and nucleic acid. We're going to look at the functions of the 4 macromolecules: carbs, lipids, and nucleic acids. Raise your hand if you're still writing. I'll give you a few more seconds. We're looking at the functions of carbs, lipids, and nucleic acids. So our first question on the left-hand side of your Cornell notes is simply, what is a biomolecule? What is it? What is a biomolecule? What do you guys know about the prefix bio? What does that mean? Living. And in 8th grade last year, with either Mr. Travis or Miss Clyett, you learned about periodic table, right? Did y'all learn that last year?
No.
If you were an IPC, we talked about the periodic table. What things are on the periodic table? Numbers. What do those numbers represent? How many protons, neutrons, or electrons are in an atom? What is another word we can use for atom? If it's one atom, then it's one not electron, element. It's one element, absolutely. If it's one atom, then it's one element. What do I get when I put elements together? A compound. What is a molecule? It's a compound. A compound or a molecule is when I've taken lots of different atoms and I've just put them together. That's all that means. So when we're talking about biomolecules, we're talking about living or once living compounds. You see how we got that just from the name? So in biology, if something is living or once living, we call it organic. Organic things are made by living organisms. Life on Earth is what we call carbon-based life. Here on planet Earth, if you're alive, probably somewhere inside of the compounds that make you what you are, there's going to be some carbon. Biomolecules consist mostly of carbon, hydrogen, and oxygen. There are some additions, but for the most part, it's C for carbon, H for hydrogen, and O for oxygen. If you haven't caught on to the trend, if I highlight it, it's what you write. Okay? Organic, made by living things, consist of carbon, hydrogen, and oxygen. Raise your hand if you're still writing here. A few more seconds. Hang in with me for a couple of slides and I'll give y'all a break. You just got to focus for maybe 2 more. Is that a deal? All right. Here we go. So if a biomolecule is organic, made of living things, and it has carbon, hydrogen, and oxygen in it, but wait, what is an organic molecule? So kind of what we just said. Organic molecules contain carbon. They're considered the chemicals of life. If there is no carbon, then it's not organic. No C equals inorganic. No carbon, it's not organic. So what did I say? Life on planet Earth is what base life? Starts with a C, ends in arbon. Carbon. It's carbon-based life. I have to brag on you guys. I got good notes from the subs on both days, and I got a list of names of some people who worked exceptionally hard on your biomolecules worksheets. So if we have time at the end of class, I'm going to call those people up, and they're going to get tickets for the next cake drawing. Okay? So very good job.
Okay, so who won the first one?
ISIS?
Yes, ISIS won. Hey. Oh, I'm sorry. Were you not finished? No, you don't have to. All right. So, who's ever played Legos? You ever played with Legos? You know how you start with one little block, and when you put multiple blocks together, it makes this bigger thing, right? And how there's a way we can make them all fit together. Molecules are kind of the same way. Yes, it was in the reading. If you've done your reading, this was in it. New heading on your C notes. This one I'm not giving you a question. I'm just giving you a heading, but this is a new chunk. So if you want to change colors or if you're just going to chunk it later, either is fine. The heading is monomers versus polymers. Left-hand side of your Cornell notes, monomer versus polymer. So if we're looking at Legos, and we wanted to make an analogy here, a monomer would be like one Lego, and a polymer would be like you built a house, right? Out of Legos. So the heading goes on the left-hand side. The next heading in your C notes. Yes, sir. If we're using an analogy, a monomer is like one Lego. A polymer would be like something you built. Monomers react with similar molecules to form a chain. Polymers are a chain that are chemically bonded together. So a monomer could also, you could look at it like one pearl, and a polymer could be the whole pearl necklace, where you've got multiple pearls coming together to form a chain. So a monomer would be like one pearl. Polymer would be like the whole necklace. You getting this? Be sure you're following along. We're going to use our Cornell notes this whole unit. So we've talked about biomolecules. They have carbon in them, make up kind of living things. And now we've talked about how you have monomers and polymers. Guess what? Some biomolecules exist as monomers that can come together to make polymers. Specifically, what comes to mind to me are monosaccharides and polysaccharides. Also, if you eat a lot of potato chips, you may have heard the term trans fat. That means there's like 3 of them, 3 of a molecule. So let's look at if there's these things called polymers that are built from smaller units called monomers. How are polymers formed? So I would put this as my, again, wrong writing utensil. I would put this as my heading on the question on the left-hand side. How are polymers formed? Who's ever played a sport and been told they need to drink a lot of water? Or been really hot outside and somebody tell you that? Why? What happens to you if you don't drink a lot of water? You get dehydrated, right? So polymers are formed in a process called dehydration synthesis. Using your prior knowledge, what do you think we're taking out if we're dehydrating? We're taking out the water. So another name for this is also condensation. So who knows, if I were to write water as a molecular formula using the elements hydrogen and oxygen, how would I write it? Anybody know? H2O. Good job, Isis. So let's read this description. We've said we know dehydrate means you lose water. We figure that if we're doing dehydration synthesis, we're taking out water. We know water is H2O. So this description says 2 hydrogen atoms and 1 oxygen atom are removed from the monomers to form water. And the 2 monomers are then joined together. So, if I were going to simplify this, I would just say water over here. If I were taking my notes, I'd write water removed from the monomers, 2 monomers joined together. That's how I would simplify that. Water removed from the monomers, 2 monomers are joined together. Two monomers are joined together. Wake up. Go ahead and take a brain break. I want you to stand up, go touch a college logo, and head back to your seat. We all need to kind of wake up, get our brains active. We're passing out, going to sleep, drooling. So stand up out of the chairs. I'm going to harass you till you get up. Come on. Stand up. Go touch a college logo. There's tons of them in the room. Go find one. Oh, there's some like right behind you, Sylvia. Go touch one. Head back to your seat. So, what do we already know? All organic molecules are made of carbon. What else? Head up, Amaya. What do we know? He said we know that all organic molecules are made of carbon. What else do we know? We know how polymers are formed. What do we have to take out for a polymer to be formed? Oxygen and which makes? We've got 2 hydrogen and 1 oxygen that makes? No? H2O is what? Water. Okay? So that's how polymers are formed. Sit down, Andrew. Not yet. So we're going to watch a quick animation that's going to walk us through this process, maybe, if it'll let me. I have a problem. Oh, she's fine. I'm going to have to go up to the laptop to click this. It won't let me click it on my iPad. So right now you're just watching. You don't have to write anything while you watch. So I fail at life. Let's just copy. Okay, Andrew, take a seat. Not right now. Here we go.
A condensation reaction joins 2 molecules together to form 1 larger molecule. An enzyme removes a hydroxyl group from 1 molecule and a hydrogen atom from another, then speeds the formation of a bond between the 2 molecules at their exposed sites. Typically, the discarded atoms join to form a molecule of water. Hydrolysis is a type of cleavage reaction. It's like condensation.
What does the
in
prefix
reverse.
hydro mean?
An enzyme splits the molecule into 2 parts.
Water.
Then attaches a hydroxyl group and a hydrogen group from water to the exposed sites. The result is 2 smaller molecules. Condensation and hydrolysis are used to put together and break apart many biological molecules.
All right. So we learned from the PowerPoint that when we remove water, monomers join together. What did you see in the video? What happens when we add water? When we add water to molecules, it's called hydrolysis. What happens to them? Do they join together or separate?
No, separate it to their own little.
They separate? Okay. So, in your notes, I want you to get this down. Water removal joins. Oh, it's not putting it up there? You're right, I sure do. There we go. It should work now. Can y'all see that, or is that too hard to see? Okay. Water removal joins monomers. Monomers. Water addition breaks apart polymers. So I'm going to do H2O addition breaks up polymers. I'll read it to y'all again. I know it's dark. You can't see it good. So water removal joins monomers. Water addition breaks up polymers. Water removal joins. Water addition breaks up. Water removal joins. Water addition breaks up. We've got about 8 minutes. Water removal joins. Water addition breaks up. Raise your hand if you're still writing that. Water removal joins. Water addition breaks up. We're going to do about 2 more slides, so hang in. So we've already answered this question in our video. You tell me, wrong writing utensil. How are polymers broken down? What do we have to add? So we add water. This is called hydrolysis. Yes, water is added. I would put this question as a left-hand thing in my left-hand column. And my answer would be hydrolysis. And I could just write water's added. You following along? It's not. No, just what we've highlighted. You only have to write what's highlighted. You can put it in your own words. Doesn't have to be exactly the way mine is. I lied about the time. Sorry. Here's what we're going to do. Just go ahead and put those notes in your binder. We'll pick up with them. It'll probably be Thursday because I'm out Tuesday and Wednesday next week. So put them somewhere safe. Bye, guys. Y'all have a great weekend.